Hello, everyone. I'm Whitney Zimmerman. I'm an assistant teaching professor in the Department of Statistics at Penn State, where I design, teach, and coordinate the online sections of the university's largest introductory statistics course. I work primarily with the Penn State World Campus sections of the course, but occasionally we offer it online through the University Park campus as well. Today, I'm going to be talking about practical methods for designing research studies and analyzing data in educational settings. My primary goal is to give you some things to think about when you're designing a study or analyzing data. As you see at the bottom, my focus is going to be on methods for measuring the impact of an intervention. Here I'm going to be focusing primarily on research questions related to change as a result of some sort of educational intervention. A lot of the time, this is change in knowledge, because we often want to know if our students have learned something, but it could also be affective, like self-efficacy, attitudes, satisfaction, or anything else that you can reliably measure. There are a lot of different research methods that can be applied in educational settings. What works best really depends on your research questions and the context that you're working in. As a bit of a disclaimer, my background is in quantitative research, so you'll hear me refer to a lot of quantitative examples today, but I do think that these methods could be used with qualitative studies as well if your goal is to make an inference from the sample to the larger population. I've broken the presentation into 4 parts. If you've taken a research methods course in any area of the social sciences, you're probably familiar with randomized experiments, pre-test, post-test designs, and quasi-experimental designs. With each of these, I'll review the basics very quickly, but I'll try to focus on the pros and cons of each method in online education research. The last area that I'm going to speak on is propensity scoring. I'm going to assume most folks are not familiar with this at all. It's more of an analysis method, but it can impact the design of a research study as well. I've been seeing a lot more of propensity scoring in the last 2 or 3 years, so I describe it as an up-and-coming analysis method that can be used with quasi-experimental designs to strengthen the conclusions that can be made. When we get to that point, I'll introduce propensity score analyses in more detail and provide some suggestions from those of you who are interested in exploring the use of those methods in your research. So Barbara, I see there's some comments about not being able to see the screen. Is that on my end or is that on their end?
I am not sure. You may want to switch to your next slide. Some folks have said something about seeing all blue. Well, there is a lot of blue in that slide, so I'm not sure if that's the issue. I also have recommended some people exit the Zoom room and come back in. I am seeing the screen sharing perfectly.
Okay, I was gonna say, I have this running on a second computer as well, and it's showing up okay there for me as well. So on the recording, at least, everybody should be able to see the slides, even if you can't see it now, I think.
This is true. Yeah.
So I'll get started with randomized experiments. A randomized experiment is an experiment, which is a research study where the researchers manipulate the treatments received by the participants. A randomized experiment also has randomization. This refers to randomly assigning participants to different levels of the treatments. Putting those 2 definitions together, a randomized experiment is a research study where the researchers randomly assign participants to different treatment conditions. Here's an example. Say that this is my sample. I have 24 students and I want to divide them into 2 groups. I'll call that my treatment group and my control group. Here, I'm going to demonstrate simple randomization This randomly assigns each participant to a group without taking any other factors into account. So each participant has an equal probability of being put into either group. You could do this by flipping a coin for each participant, or I like to use a random number generator in Excel, where I'll randomly assign a number to each participant. If it's even, they go in the treatment group. If it's odd, they go in the control group. This randomized experimental design is sometimes referred to as the gold standard of educational research because it allows us to make causal conclusions. Without the randomization, so without randomly assigning participants to the different groups, we can't definitively attribute any differences to the treatment. Now let's look at some of the pros and cons of using randomized experimental designs when we're conducting research, specifically in online education. So the first pro I've already mentioned, it's that we can make causal conclusions. In other words, we can attribute any observed differences to our intervention because with randomization, the groups are assumed to be comparable at the beginning of the study in terms of any confounding or lurking variables. Moving down to the cons, even with this so-called gold standard experimental design, we still need to worry about sampling issues and threats to validity. In other words, incorporating randomization into your study is not going to solve all of your problems. Sampling refers to how your sample is taken from your intended population. So how do you go from this population of all of the individuals you're interested in learning something about to the smaller sample that you can actually collect your data from? There are many different ways to do this. In fact, the statistics department at Penn State has a full graduate level course just on sampling because it's such an important part of designing research studies. It's important because when we're testing the effectiveness of an intervention, we usually want to be able to generalize back to the larger population. And in statistics, we call this inference. In order to make this inference, the assumption of most statistical analyses is that our sample was randomly drawn from the population. We can achieve this by using probability-based sampling methods, the most basic being simple random sampling, where every member of the population has an equal probability of being selected to be in the sample. There are more advanced probability-based methods. In addition to simple random sampling, stratified sampling and cluster sampling methods are two other probability-based methods that you may see in educational research. These probability-based methods are typically preferred to help avoid sampling bias. But many times with social science research, it's not practical to use probability-based sampling methods. And in those cases, we often fall back on non-probability-based methods, which we see here on the bottom. Convenience sampling is really common in educational research. You might also hear this called opportunity sampling or accidental sampling. It's when you obtain a sample that is just readily available to you. For example, you may not have access to all of the students at your institution, but you know a few instructors and you get them to agree to let you collect data from their sections. Volunteer sampling, you've probably seen as well. For example, you may have seen posts on Facebook or LinkedIn looking for people who want to take an online survey. The problem with this is that the sample is probably going to be biased. In other words, not representative of the whole population or your whole intended population. If you're asking for volunteers, people who are interested in the topic are probably going to be more likely to click the link and participate. If you're advertising on social media, you're limiting yourself to people with accounts on those sites, and you're probably going to get more people who are more active users on those sites. If someone doesn't have an account or they rarely go onto LinkedIn, they're not going to see your link and they're not going to be able to participate. So even if you have the randomized experimental design, if your sample isn't representative of your intended population, you won't be able to generalize your results. I'd also mention that threats to validity are still issues with randomized experiments. I want to review a few of the most common threats to validity before I top off my list of pros and cons. While randomization will ensure that your groups are comparable at the beginning of the study, there are lots of things that could occur during the study that could impact your final conclusions. And we call those threats to validity. There are many different threats to validity, even with randomized experiments. If you're doing research with students, these are some of the issues that I've seen come up even with randomized experiments. The first is diffusion of treatment. The graphic here depicts an example of diffusion in a scientific sense. Over time, the treatment, which in this picture is the purple dye, spreads, and eventually the whole cup is purple. So even though the treatment was just given to a small section, over time, it expands and the whole cup is filled with the treatment. Diffusion of treatment in social science research is similar. This is when we give the treatment just to our treatment group, but students talk or instructors talk across groups, and over time, the control group learns about the treatment and may gain some benefit from that. So your control group isn't a pure control group. For example, my department was considering changing our introductory curriculum a few years ago. We designed a study to compare sections taught with our older methods to sections taught with the new method that we were considering switching to. All of the instructors knew what was going on. They were all very familiar with both approaches. And actually in the online sections of the course, we had already started incorporating some of the new methods into all sections of the course. So even the sections taught with the old textbook had some activities from the new textbook mixed in because we had known for a while that those were best practices. In other cases, particularly in our on-campus sections of the course, students talk. The majority of students are required to take the course that I work with on campus. There's about 2,000 students enrolled each semester. With that many students, they're bound to have some interaction with someone using the opposite curriculum. On top of all of that, there's Google. Students in the new curriculum could easily Google one of their homework questions and find a solution that uses the older methods and vice versa. Next is the Hawthorne effect, named after Hawthorne Works, which was a factory. A research study was done there in the 1920s. A company had commissioned to see if different levels of lighting impacted work production. When the researchers came in, they changed the lighting, they observed the workers, and they saw that productivity improved. So their initial conclusion was, yes, changing the lighting improves productivity. But then when they left, so the researchers left, but they left the lighting there, productivity dropped back to where it was before. And they realized that it wasn't the lighting that was having an impact, but it was probably that having the researchers present and observing them that motivated the workers to be more productive. Thus, we have the Hawthorne effect, which occurs when people act differently because they know they're being observed. If you're doing research in an online course, it may be easier to prevent this because students can't literally see you in the room observing them, but you still want to be careful about what you say to the students and even what you say to instructors who are participating in your research. A lot of times the institutional review board will require you to get students' permission to participate in your research. So you need to think about exactly what you're saying to them and whether or not that could impact how they act during the study. I've seen the Hawthorne effect lumped together with the novelty effect, but I like to think of them as being different. The novelty effect is when individuals are motivated by something that is new and novel. For example, if you introduce a new technology into a course, at first, the students may think that it's really exciting, it's different from what they're used to, and you can see an increase in their motivation. But over time, it loses its appeal. This is often a concern for me when I do shorter research studies. I've done some work with instructional videos, and if I'm showing students just 1 or 2 new videos, if it's in a new format for them, it's possible that their motivation could be piqued by its novelty. So it's important to follow up those shorter studies with longer full semester studies to make sure that it's not a novelty effect that's going to wear off once they get used to that instructional method. And last threat to validity that I'll talk about is experimental mortality. It sounds really bad, but it's really just referring to participants dropping out of the study. If you're doing research in a course, this would be students dropping the course or withdrawing from the institution. We're often still really interested in these students because they can tell a different but yet very important story. Depending on what your outcome of interest is, we can sometimes find a way to still include these students in our analyses. Experimental mortality could also refer to students who withdraw consent. So partway through a study, they could decide that they no longer want to participate. In my experience, that's usually not an issue unless you're doing something that is more invasive or requires students to do extra work. Going back to the pros and cons of randomized experiments, I mentioned earlier that this is the gold standard of experimental designs, but with that said, it's not always realistic in educational settings. If you're designing a shorter study in a laboratory type setting, this might be a great option for you. For example, my dissertation compared 2 instructional methods. Start to finish, it was about an hour. It was a short study being conducted in a laboratory setting, so it was relatively easy for me to randomly assign students to different conditions. It can be more challenging with longer studies and those not in laboratory type settings because of some of the threats to validity that I just discussed, and also logistically, it's sometimes impossible to be able to randomly assign students to different treatment conditions. So for that reason, we see a lot of quasi-experimental designs in online education research, which lack randomization. Before I move on to quasi-experimental designs, I want to look at pre-test, post-test methods, because those are also often used in educational research. So this method is also referred to as repeated measures. In the most basic design, you have one group of students and you measure them twice using the same scale. Then you would analyze the change in scores. I'll talk about the pros and cons of this method. Then I'll introduce a slightly more complicated design that helps address some of the problems with the basic pre-test, post-test design. The first pro is that you can have greater statistical power compared to a design with just a post-test, no pre-test, or compared to an independent group's design. Now, if there aren't any differences between students at the beginning of the study, for example, if all of your students score 0 on the pre-test, then the repeated measures are not going to help you at all. If there's no differences at the beginning, then you might as well just have a post-test only design. But if there are differences between students at the beginning, the pre-test will take that into account. Because you typically have greater statistical power, they require a smaller sample size. When designing a study, you should run a power analysis to confirm that your sample size is large enough to detect the differences that you're hoping to see. A power analysis for a repeated measures design should result in a smaller necessary sample size compared to one for an independent group's design. And pre-test, post-test designs tend to be logistically straightforward. They're relatively easy to design because you only have to have one group. For the cons, one of the biggest criticisms with the basic pre-test, post-test design is the lack of a control group. With no control group, you can't conclude that your intervention is what caused any changes. History and maturation are two threats to validity because of this. History refers to all of the things outside of your intervention that students experience during your study. For example, if you're looking at pre-test, post-test, beginning and end of a semester, while students are taking your class that semester, they're probably taking other classes. They may be working, they're reading things on their own. All of those other experiences can impact their performance on your post-test. Maturation is similar, but it usually refers more to natural development that happens over time. Another potential issue is the testing effect. The pre-test and post-test measures need to be equivalent. If the measures aren't equivalent, then you don't really have a repeated measures design. You really just have a post-test with a covariate. Usually, we use the same survey or the same test at both points. The problem with this is that people can learn from the pre-test. They could go home and look up the answers after the pre-test, or even if they're not that proactive, when the topic comes up later during the course or whatever your intervention is, it can stick out to them because they've seen it before. So they've been primed to look for that specific information. One way to get around this is to say that the pre-test is part of the intervention. For example, saying in real life, you would really give students this pre-test at the beginning of the course or the beginning of the lesson. Another way to address these cons is to use a more complicated design. And this is the Solomon 4-group design. It gives you every possible combination of pre-test and treatment. In terms of pros and cons, this design gives you a control group. So you can compare your treatment groups to your control groups to test for the effectiveness of the treatment, both with and without the pretest. Recall one of the criticisms of the basic pretest post-test design was the lack of a control group. You can also determine if there's a testing effect, because now you have groups with and without the pretest that you can compare. In terms of cons, it is more complicated because now you have 4 groups instead of just 1 or 2 groups. Logistically, this could make things more difficult for you. You're probably going to need a larger sample size. And in terms of analyses, it's going to be more complicated because now you have to do multiple comparisons to test for treatment effect, testing effect, and all of the possible combinations of those things. Just like we saw with randomized experimental designs, we still need to worry about sampling issues and threats to validity. Everything we saw earlier applies here. And randomization is still required for a causal conclusion. So the Solomon 4-group design addresses the criticisms that we saw with the basic pre-test, post-test, but it can also complicate your research study and it may not be practical. You may not have the sample size to divide into 4 groups. If you can't randomly assign participants to groups, you still won't be able to make the strongest causal conclusions. In reality, the research study design that we probably use most often in educational research, particularly if you're on a low budget or have other restrictions, is the quasi-experimental design. This is a study that resembles an experimental design. So from the outside, at first glance, you might say that looks like a randomized experiment, but then when you look a little closer, you realize it lacks randomization. In educational research, we often use pre-existing groups, and that would be an example of a quasi-experimental design. Here's an example. You want to compare an older curriculum to a newer curriculum. There are 2 sections of the course being taught. Students self-enroll in these 2 courses. They're not randomly assigned. Logistically, it may not be possible to randomly assign students to different sections of a course. And because the curriculum needs to be assigned at the course level, your best option is to assign one section to the old curriculum and the other section to the new curriculum. You could randomly determine which section will get which curriculum, but since the students aren't being randomly assigned to groups, it's still a quasi-experimental design. In terms of pros and cons, logistically, it's usually the easiest to implement. This is particularly true if you're doing research in a real classroom setting. In other words, you don't have a laboratory setup, which I think is the case for most of us. You can use pre-existing groups and assign different treatments to the different sections. One of the reasons why I often lean towards quasi-experimental designs is that I feel like they could be more consistent with real life. This is sometimes called ecological validity. Typically, online students don't take classes in a controlled laboratory setting. They take classes with other students, they interact with those other students, and if we were to randomly assign students to different sections, the demographics of those sections may not match what we usually see in real life. For example, the course that I teach, we have 12 to 24 sections every semester, but there are some naturally occurring trends or differences between those sections. Students who enroll first, who are either going to be military students or more senior students, students who are online the first day, the first minute that they could possibly sign up for classes, end up in the lower number sections. The students who wait until the last minute to sign up, who are often the students who failed the class the previous semester and realize they have to retake it, those students end up in the higher number sections. So within each section, we don't have a naturally occurring, random combination of personalities and prior experiences. So with the quasi-experimental design, we can maintain the demographics and the relations that we usually see within the sections in real life. And my last pro here, you sometimes need to use quasi-experimental designs to avoid potential ethical issues. Common example, extreme example, outside of education is if you wanted to study the impact of smoking on pregnant women. It would not be ethical to recruit a group of pregnant women and randomly assign half of them to smoke and randomly assign half of them to not smoke, because we know that smoking is harmful. Instead, you would use pre-existing groups of pregnant women who either smoke or don't smoke by their own choice. An example that you might see in online education, you may want to compare students who use an optional free tutoring service that your college provides to students who choose to not use the optional free tutoring service. It wouldn't be fair to tell some students that they're not allowed to use the tutoring service, and it could be nearly impossible to force other students to go to the free tutoring service. So instead, what you would do is you would look at the pre-existing groups of students who choose to use or choose not to use the service. Now, those groups are likely different in other ways, but after I finish the cons list here, we'll look at propensity scoring methods, which can address that concern. As with every design that we've seen, we still need to worry about sampling issues and threats to validity. If you're using a quasi-experimental design, you probably have a convenient sample, which means that you're limited in the generalizations that you can make. The threats to validity that I talked about earlier, so diffusion, the Hawthorne effect, the novelty effect, they're all still concerns here. The biggest downside of quasi-experimental designs is that you can't make definitive causal conclusions. Without randomization, we can't rule out all possible confounding variables. The good news is that there is a method for analyzing data from observational studies that can improve the strength of the conclusion that you can make. It's not quite the gold standard of the randomized experimental design, but it'll get you closer to a causal conclusion. And with the type of research a lot of us are doing in online education, I think it's really important to look at propensity scoring and be aware that this is an option that exists. And this is the last section of my talk today. I really wanted to include this because I think, or I hope, that we'll see more of it in online education research in the future. I first found out about it 3 or 4 years ago. I was at the Northeastern Educational Research Association's annual conference, where I signed up for a pre-conference workshop that was hosted by a few folks from James Madison University. And they gave a really nice presentation on propensity scoring. And that's where I first learned about how it could be used and applied to observational research. So it's still relatively new to me, but I think as statistical software gets more powerful, we'll start to see more advanced methods like this used on a wider scale. In the graphic I created to symbolize propensity scoring, you can see that the participants in the two groups are matched. This analysis method matches participants or groups of participants after the study is completed on the basis of what researchers identify as being relevant variables. I'm going to try to not get too technical. Propensity score analysis is more complicated than the t-tests, ANOVA, linear regression that we often see in online education research. But with that added complexity comes the ability to make stronger conclusions. I'll use the example where we had a tutoring program and students either used the tutoring program or declined to use the tutoring program. Let's say that what we really want to know is, does using our tutoring service improve final exam scores? At the end of our course, we could pull the students' final exam scores and compare them for two groups. Maybe the students who did use the tutoring service had an average score of 92 points, and students who did not use the service had an average of 88 points. We could do an independent t-test here to compare the two means, but that wouldn't completely answer our question. If you try to publish these results, you'd probably get feedback like this. Well, in my class, the better performing students are the ones who use the tutoring services. Or, traditional aid students probably have more time than adult learners to use the tutoring service, and they're usually better. So in other words, the problem with this design is that our two groups may be different in more ways than just tutoring and no tutoring. We can't say that the tutoring service is what caused the scores to be different, because students self-selected whether or not they wanted to use the service. The students who choose to use it and the students who choose not to use it could be different in some other ways. To strengthen our argument, we can use propensity scoring methods when we compare the two groups. This will give us some evidence to argue against the folks who say, yeah, but What about students' prior academic performance? Or what about their age? A propensity score is the probability of receiving a treatment given baseline characteristics. These scores are then used to balance the two groups before we make our comparisons. In order to compute propensity scores, we need to have some baseline data. You could hear these called covariates. In this example, possible covariates or variables that could impact our results could be GPA, age, employment status, gender, credits completed, credits currently enrolled in, and number of online courses completed. Essentially anything that someone could say likely or possibly impacted the students who ended up in each of the groups. Then where it starts to get more technical is that those variables are used to compute a propensity score, which is a measure of each individual's probability of receiving the treatment. There are different ways to do this. The common method is using logistic regression, which is regression where the outcome variable that's being predicted is the probability of being in the treatment group. So for example, we could take the first person. They have a 3.5 GPA, 24 years old, work part-time, identify as a woman, have completed 32 credits, are currently enrolled in 12 credits, and have taken 4 online courses. We put all these variables for all these people into the logistic regression model, and for this particular individual, we could say the propensity score is 0.75. Once you have a propensity score for each individual, there are a few different ways that you can use them. I'm just going to talk really quickly about one of the common options, which is propensity score matching. This method matches individuals in the two groups who have similar propensity scores. This example is a one-to-one matching, which is probably most common, but there are other methods. Depending on how different the two groups are, there may be some participants who don't get matched, and they would have to be left out of any following analyses. Once you have your pairs, the next step would be, in this case, to compare the final exam scores using either paired data or treating them as independent groups. And I will note there is some disagreement as to whether or not the two groups should be treated as matched pairs, in which case, if you're comparing means, you'd be doing a dependent means t-test, or if they should be treated as two independent groups, which, if you're comparing means, would be an independent means t-test. My advice would be, for anyone who's considering using this, at least for the first time, consult with a statistician or a data scientist to really talk through what makes sense in your specific research project. In terms of pros and cons, with the propensity scoring approach, observational data can be analyzed in a way that mimics a randomized experiment. The word mimics, I'm borrowing from this Peter Austin article, which is cited at the bottom here. I could not think of a better way to describe this. If you're interested in learning more about propensity scoring, this is an article that I would definitely recommend. It takes a very applied approach and goes into great detail without getting too technical. There's a few equations in it, but for the most part, it's about the concepts and less about the math. Another pro is that you can make stronger conclusions compared to if you used a quasi-experimental design and just compared existing groups without making any sort of corrections. With propensity scoring, you have a rebuttal to the reviewers who are saying, yeah, but students who are better off to begin with use the tutoring service. Or, yeah, but you have more adults in the group that didn't use the tutoring service. And we know that, adults perform differently than traditional students on this exam. Because you're balancing the groups using those possible confounding variables, you're saying that the two groups are comparable in terms of all of those other variables. In terms of cons, propensity scoring requires data from more variables. You need to think ahead and collect data on the variables that you think reviewers or whoever is reading your research are going to argue with you about. For me, this is the most difficult part. I work with one specific course, and I don't have access to transcripts or official demographic data for the students. So when I do research, I really need to plan ahead and administer a survey at the beginning of the semester to collect all the data of all the covariates that I want to include in the model. If I forget something, I usually can't go back and get it later, because once the semester is over, those students are gone and I don't have access to them or their data anymore. Some baseline similarities are necessary. If there's not enough overlap between the two groups, when you go to make the matched pairs, you're gonna have a lot of people who don't have a partner. Or even if you're using one of the other methods, you could still end up in a situation where you potentially have to throw away a lot of data, which reduces the power of your test and also has a negative impact on the validity of your conclusions. Because you can imagine if you started out with 1,000 people, but by the time you get through the propensity score matching, you're down to like 40, you've lost a large proportion of your sample, and there's a lot of people who aren't being included. Propensity scoring does not guarantee comparable groups. There's always a chance that you forgot to include a variable, or there's a variable that you weren't able to get data on. It'll only balance the groups on the variables that you were able to include, which is why it's still not as strong as the randomized experimental design. And finally, possibly one of the biggest barriers that I see in the field of online education research is that these methods are more complicated. It can be done with statistical software like R, SAS, Stata, but typically you need to have a pretty high understanding of like logistic regression and propensity score analysis to be able to carry it out on your own. I think it'll take some time for propensity scoring methods to become more mainstream, but hopefully we'll see it used more often in the future as folks become more aware of what it is and as it becomes easier to do yourself in statistical software. That concludes the presentation I had prepared. I think Barbara has been saving some questions for me.
Yeah.
How much time do we have until folks start coming back from the other room?
Folks are going to start to come back in just a moment or two, but we do have one question, and I'll go ahead and ask that. It looks like another question may be coming in. So we do have a couple of minutes for questions. We'll do those, and then I'm going to stop the recording and let you stop screen sharing, and then I'll go ahead and screen share for our closing and begin the recording for that. So this first question is, how can you tell if there is a novelty effect? A study would need to be long-term. You can't do this short-term. So how many terms would you consider to be valid?
So short-term versus long-term in terms of testing for novelty?
Yes.
For me, I'm working with one introductory statistics course. So I'm really only concerned with those 15 weeks. So for me, a long-term study would be all 15 weeks. Because if there's going to be a novelty effect, if it wears off after 15 weeks, I don't want to say I don't care about it, but I mean, my course is 15 weeks, so if the novelty effect can maintain itself for 15 weeks, that's great, because that's all the longer my course is. Um, I think a lot of times it depends. Well, depends on the research study. Depends on like what the intervention is for. Because, like I said, I'm working with one course. It's a set amount of time, 15 weeks. So that's my long term. What I typically do, or what I would do if I wanted to test for the novelty effect, or if I was testing out a new intervention. For example, when I tested out long lecture videos in my class, I started short. I started with 3 weeks. That was successful. So the next semester I did 12 weeks, or sorry, the next semester I did 6, and then the following semester I did 12. So my preference is to start short term and then add on till I get to the maximum 15-week mark.
Okay, thanks. We do have a couple more questions. What percentage similarity does there need to be in order to pair people? Is there a range or is it dichotomous?
Ooh. So you're matching them based on their propensity scores. When you're actually running it, I think you can set how you want to do the matching, because you could do it with like, it has to be within 0.05 or something like that. There's also different methods where you could do groups of people. I've seen that used if like one group is larger than the other group. So if you have 100 people in the treatment group and 500 people in the control group, you could do like a group matching, and you would make the decision like how wide you want those bands to be for people to be matched together. That's something that I would probably want to sit down with the statistician with, and then run a few different options and look at what the distributions look like with different options.
Okay, thanks. Another question. Do you have any general advice regarding sample sizes in this type of research?
So with propensity score analysis, you do need to have a larger sample size. Um, Now, what is larger is always going to be subjective. It's going to depend on how much overlap you have between those groups. Again, that's probably a situation where I would say sit down with the statistician and talk about the power analysis before you collect data, because if you're not going to have enough overlap between the two groups, then there's really no point in doing propensity score analysis. They would probably point you in a different direction. Yeah, I would say my general advice, if you want to do this for the first time, is to find a statistician or a data scientist who is willing to sit down and talk with you about the method and your particular research study. Because you don't want to be off there trying to do it on your own, and you also don't want a statistical expert who knows absolutely nothing about the context of your study. What you really need is a good team of people, you with the expertise in the research question and everything that you know about the students, and then the statistician or data scientist who has expertise in the statistical methods.
Okay, thanks. We have another question. Is diffusion more age dependent? For example, higher ed versus K-5 or K-12. Is there one way you would use one over another based on the types of education delivery method?
So diffusion, I see a big difference between online and on campus. I know for my online students, they don't typically socialize out with each other outside of class, because they're typically adult learners who are logging on, taking that class, and then logging off. Whereas the on-campus students have more time to socialize with one another. They're going to see each other outside of class. If they have friends or a roommate, they're going to talk about, when they took that class, what it looks like. So I see a big difference between online and face-to-face. Higher ed versus K-12. That's a really tough call. I would think in K-12 you might see more diffusion in terms of teachers talking as opposed to students talking. But in both cases there, if it's face-to-face, I think you're more likely to see diffusion treatment than in the online setting.
Okay, and then there was another follow-up to that, asking about the pre or post-test method and how determining the ages of what method you would use.
Oh, okay. I think they might be referring to maturation. Yeah, maturation you're going to see a lot more with younger people than you will with older people. And that's a problem with the pre-test, post-test, because you can think like if you're measuring reading ability in preschool students, they're naturally developing at that age much quicker than if you're looking at adult learners. So yeah, for the maturation effect, you're going to see it a lot more with younger students than you will with adult students.
Okay, and I see others are joining us for the closing session, so I'm just going to do this one last question. If you are using a QED where one class is analyzed without intervention and the other class both taught by same faculty over different semesters with intervention, would you propensity score match between the control and treatment or within the control and treatment?
Between the control and treatment groups, because we know that demographics each semester can vary. I know for me, fall semester I have more freshman students. Spring semester I have more upper level students. So I would match fall semester versus spring semester, which in that case could also be treatment group versus control group, to make sure they're balanced on all of those covariates.
Okay, well, thank you so much, Whitney. There was just a wealth of excellent information. I hope that everybody is seeing how to contact Whitney if you have questions. At this point, I'm going to stop the recording and let Whitney stop sharing.